Welcome to Spaceverse, your portal to cosmic adventures. This young star is surrounded by a protoplanetary disk separating the wings of the butterfly. Across the galaxy, stars are born in immense clouds of gas and dust, stellar nurseries where gravity slowly but persistently pulls material together. These regions are cosmic cradles, where something incredible happens, clouds collapse, heat builds, and nuclear fusion sparks the birth of new stars. But that's not where the story ends. Around many of these newborn stars, swirling gas and dust flatten into what astronomers call protoplanetary disks. These disks are not just leftovers from star formation. They are nurseries within nurseries, the very places where planets are forged. By studying these disks, astronomers get to travel back in time. Every image is like a fossilized record of processes that occurred in our own solar system more than 4.5 billion years ago. Looking at them is like seeing a snapshot of Earth, Mars, Jupiter, and Saturn in their earliest, embryonic stages, long before they became the planets we know today. So, what exactly are we looking at? Recently, the James Webb Space Telescope, better known as JWST, turned its powerful gaze toward one such region. What it captured is nothing short of breathtaking. The telescope caught sight of a protoplanetary disk and the young star at its center, seen from a rare edge-on angle. That star, known by its rather technical classification IRAS 4302 plus 2247, or more simply IRAS 04302, is a protostar, a star still in the making. At first glance, the image is visually stunning. The star appears to split a dark band of dust right down the middle, while vast wings of glowing material fan out above and below. Astronomers were immediately reminded of a butterfly in flight. And so, this object earned the nickname the butterfly star. Let's put its size into perspective. The disk of material around IRAS 04302 measures about 40 billion miles wide, or 65 billion kilometers. That's roughly 450 times the distance from Earth to the Sun. Just imagine a gigantic, cosmic-sized record spinning in space with a young star right at its center. That's the scale we're dealing with. Now here's something particularly fascinating. The dust surrounding the star actually works in our favor. Normally, stars are so bright that they outshine everything around them. But in this case, the dust dims the central star's glare just enough for Webb to capture the intricate details of the disk. And because Webb operates in the infrared part of the spectrum, it can pierce through dust clouds that would block visible light. The result? A spectacularly detailed image of the butterfly star that combines beauty with profound scientific value. Where exactly is this happening? The butterfly star lies about 525 light-years away in the constellation Taurus. To us, that might sound impossibly far, but in galactic terms, it's practically in our neighborhood. Taurus is one of the best-studied star-forming regions in the sky. Astronomers often look there when they want to understand how stars and planetary systems come to be, because it's close enough to observe with remarkable clarity. And why is this particular view so amazing? Well, capturing a protoplanetary disk edge-on is extremely rare. Most of the time, we see these disks face-on or at a tilted angle, making it harder to distinguish the layering and movement of material. But when a disk is aligned edge-on, it's like peeking inside a cross-section of a recipe in progress. You can observe how the ingredients are distributed and how they're beginning to mix. For scientists, this perspective is priceless. It allows them to study how dust grains within the disk behave, how they settle into thin layers, how they grow into larger clumps, and how they migrate inward and outward over time. Each of these processes is essential in the long road to planet formation. Think of it this way: dust grains are the seeds of planets. Alone, they're microscopic, like the dust you'd brush off a bookshelf. But given enough time, they collide, stick together, and form pebbles. Those pebbles merge into rocks, the rocks into boulders, and eventually these objects form the cores of planets. If the conditions are right, gas and ice can accumulate around those cores, building giant planets like Jupiter and Saturn. All of this happens within these swirling protoplanetary disks, just like the one surrounding the butterfly star. But let's take a moment to appreciate how extraordinary this is. We're watching, through Webb's eyes, the earliest steps of planetary construction, a process that once took place here, in our own solar system, billions of years ago. Every planet we see today, from tiny Mercury to distant Neptune, began as dust grains in a disk around a young star. Even Earth, the planet that eventually developed oceans, continents, and life itself, started as nothing more than particles drifting in a stellar nursery. The butterfly star gives us a unique opportunity to study those conditions in real time. Scientists can analyze how the disk's thickness changes at different distances from the star, or how its composition might lead to the formation of rocky planets versus gas giants. They can also model how material interacts with radiation from the young star, shaping the disk's future evolution. And this isn't just an academic exercise. Understanding protoplanetary disks has direct implications for the search for life beyond Earth. If we can figure out how often planets form, what types of planets are most likely to emerge, and under what conditions they develop atmospheres or oceans, then we can better estimate how common potentially habitable worlds might be across the galaxy. The butterfly star is one example among many, but it's a particularly vivid one. Its wings are more than just a pretty picture, they are a living laboratory for astronomers trying to decode the steps of cosmic creation. Imagine being able to compare different disks at different stages. Some, like IRAS 04302, are still very young, with dust just beginning to clump together. Others are more evolved, where gaps in the disk hint at the presence of newly formed planets carving their orbits. By putting these snapshots together, astronomers can build a timeline of how planetary systems grow, mature, and settle into stability. And the Webb telescope is revolutionizing this field. Before Webb, telescopes like Hubble and Spitzer offered glimpses of these systems. But Webb's infrared capabilities bring a level of clarity we've never had before. It's as though astronomers were peering at the cosmos through foggy glass, and suddenly someone wiped it clean. Looking at the butterfly star also inspires us to think bigger. It's easy to forget that our solar system isn't unique. The same processes that formed Earth are happening right now in countless other places. Some of those worlds may one day host life, civilizations, or even explorers looking back at us. Each protoplanetary disk we study brings us closer to answering one of humanity's oldest questions: are we alone in the universe? And yet, there's something profoundly humbling about it. We're watching nature's grandest act of recycling. Stars are born, live, and die, scattering material back into space. That material, enriched with elements forged in stellar cores, gathers again into clouds, collapses into new stars, and spins into new disks. Planets form. Perhaps life emerges. And the cycle repeats. The butterfly star is just one small glimpse into that cosmic rhythm, but it's enough to remind us how deeply connected we are to the universe. So the next time you see an image from the James Webb Space Telescope, remember, it's not just a pretty picture. It's a story billions of years in the making, written in dust and light. The butterfly star is more than an image. It's a message from across the galaxy telling us how worlds are born, how systems evolve, and how our own cosmic neighborhood came to be. And somewhere out there, in another disk around another star, a new Earth might just be taking shape. The butterfly star is just one reminder that the universe is alive with creation, and that our own story began in a disk of dust just like this. With Webb's eyes, we're watching new worlds take shape, perhaps even new Earths. And that's it. Thanks for joining us on this journey through the cosmos. Until next time, keep looking up, because the universe is always writing its next chapter.